So now we're going to move on to the empirical rule. The empirical rule applies when your data is bell-shaped, which we call normal. Remember we talked about normal distribution a few other times? If it's bell-shaped, and what it says, there's a lot of symbols this pen is time. A lot of symbols on that picture on your notes there. Where's my black pen? I had a black pen. I lost it. It disappeared. I'll find it. So notice in the middle here, see if this one shows up better. No, it doesn't. I have to go hunting for my black. Oh, I found my black pen. Look at that. There's a mu in the middle. What's mu?
Population mean?
Population mean. If your data is bell-shaped, that's a very steep bell, but if it's bell-shaped, the population mean is what you would expect to be right in the middle. That's why the mu is in the middle. You expect more people to have that number than anything else. And then these little sigmas down here represent what?
Population.
Population
Standard.
deviation. This bell-shaped curve, by the way, I get a little sloppy. These little edges here get closer and closer and closer to the x-axis without ever touching it. I get a little sloppy in how I draw it. If you look at it on your paper on page 29 there, it looks like they're touching. The problem is they're so close you can't really tell the difference. But technically they just get really close and hang on to that. They never touch, but they're so close they might as well eventually. It's so tiny. It'd be like if I asked you to paint underneath there. At some point you wouldn't need any more paint because it's so skinny that you can't fit your paintbrush in there, right? And then so these little sigmas here, in a way they should actually have like little plus signs in them because we're going to add sigma to get to the next one and we're going to add sigma to get to the next one and keep counting by standard deviations. So we're saying start in the middle with your mean, add the standard deviation, add the standard deviation, add the standard deviation. And if I'm going to the left, guess what I'm doing?
Subtracting.
Subtracting the standard deviation away from the mean. I'm going to add and subtract there. And before I talk about the rule, I'm actually going to label this to match the example underneath. It'll make way more sense. Let me put it here. So I'm going to draw that same picture. You can just label it right underneath it if you want. Look at the example there about the heights of women. It says that women heights have a bell-shaped curve with a mean of 161 centimeters and a standard deviation of 7. So what am I going to do with the 161?
In the middle.
Put it in the middle. 161 goes right in the middle. And then I have to mark my scale. If you're drawing them by hand, I have this one drawn for you. If you're drawing them by hand, see where it's like curving down and then curving up? Right about here, like where it stops going down and starts flattening out. That's usually 1 standard deviation away. Roughly like this, evenly spaced. I'm going to add and subtract the 7 now. 7? Yes. So the next number over here would be 168. If I add 7 again, 175, and I add 7 again, 182. We all right where those numbers are coming from? Adding the standard deviation. And then if I go this way, I'm going to subtract the standard deviation. So 161 minus 7 is 154. And if I subtract 7 again, I'll squeeze this in here a little bit better. 140? I'm subtracting in my head. Tell me if I'm wrong. Okay, I got my subtraction down for the day? We're good. Okay, so this number line describes women's heights. We would expect most women to be around 161 centimeters. Some people are taller, some people are shorter. Hardly anyone's taller than this. Some people are. It's a little skinny little sliver over here. And hardly anyone. Most people are closer to the middle. And then you can go further and further out. So this represents our bell-shaped curve. Now let's talk about this empirical rule up above. It says about 68% of the data are within 1 standard deviation of the mean. Within 1 standard deviation of the mean. What does that mean to us?
154 to 157.
Ah, 154 to
168.
to 168 he means. So let's point at it. So these people are 1 standard deviation below the mean. These people here. These people are 1 standard deviation above the mean. Just from here to here. Oops, right there on the line. And everybody in between there, if I kind of like connected this again, everybody in there is no more than 1 standard deviation away from the mean. No more than 7 away from the middle. See how I got that?
Because it's 7 and 7.
Because I added 7 and I subtract, that's why I counted by 7. This person is exactly 1 standard deviation higher than the mean. This person is exactly 1 standard deviation lower than the mean. So all these people are 1 or less standard deviations away from the mean. If we drew lines going straight up from here and shaded this in. Now your picture's probably better than mine because I freehanded this one. It should be that about 68% of this data, of this picture, is shaded. 68% is around 2/3, roughly. 2/3 of it is shaded in now. Do we agree with that? Your picture's probably better than mine. So we're saying that around 2/3, 68% of people are all going to be within those height ranges. More than half of us, for sure. So the rule is 68% are within 1 standard deviation. 95% are within 2 standard deviations. So if we start in the middle here at the mean, 2 standard deviations takes us out to here, 2 steps above, all the way out to here. Or 2 steps below takes me to here. And so imagine if I shaded everybody in between there. I'm going to make it polka dotted. Otherwise it's going to be too messy. This should now visually be 95% of it is shaded. And it should look like 95, like what, 5% left? Hardly any left. So 95% are between these 2 heights. And then finally, the third one is 99.7 are within 3 standard deviations, which is hard for me to say apparently. 3 standard deviations. If your picture looks like mine, there's hardly anything left after you go between here and here, right? If we, I guess I could do all over here. Giant stripes here. The blue stripes go all the way from here to here. That's not everybody. Not all women are between 140 and 182 centimeters tall. What percent are not in there?
So
I'm hearing 0.3%? 0.3? Where are we getting 0.3?
It's what's left from 99.7.
Yeah, you think 100% is all women. If you subtract 99.7%, you're left with 0.3%. These little, what we call tails, there's like a little tiny sliver over here and a little tiny sliver over here that you can barely see. In there is 0.3%. A few women, just a few. It's like 3 out of every 1,000 women. 3 out of every 1,000 women are either that tall or that short. So that's the empirical rule. Some people call it the 68, 95, 99.7 rule. Because it's always those numbers. 68% are here, 95, 99.7. Okay with the rule, what it tells us? Now we should be able to quickly answer questions A and B there then.
Kind of.
Question C might be tricky.
Yeah, that's
What percent of women are between 147 and 175? I heard some people over here say 95%.
Yeah, that's right.
And she's agreeing with them. Where'd we get that? I didn't do any work.
Because it's 2 values, 2 standard deviations from the mean.
147 to 175. Remember, this is mu right here in the middle. So she says that's 2 standard deviations below. That's 2 standard deviations above. So all those people are within 2 standard deviations. They're not more than 2 standard deviations away. And that's what the rule tells us. That's 95% are within 2 standard deviations. Okay with that one? There's no work to do besides recognizing it was 2 steps away. Alex, are you good?
Yeah, I'm good.
Okay. You have this look on your face like, what is she talking about?
Processing.
It's all right, processing is good. I just want to make sure you don't have questions. Okay, how about B? 99.7% of women are between what 2 heights?
140 and 182?
140, she says, and 182. Where'd she get those?
They're 3 standard.
She knows where she got them. Somebody else help her out. How'd she get that?
That's 3 standard deviations.
Thank you. That's 3 standard deviations away. 1, 2, this is 3 standard deviations away, and 1, 2, this is 3 standard deviations away, and that's the 99.7 part of the rule. That's not too bad.